The video stopped, but we're back. So we need to apply the 255.255.0 to the encapsulation.1q sub interfaces, because this is what's going to allow the entire subnet to communicate with the router in order to forward packets between layer 3 down back to layer 2. So it's essentially between networks. So let's go ahead in our router 1 and configure our sub interface. And let's go ahead for VLAN 40, 50, and our 60 on router 1. And remember, we do copy running config startup config to save all of our work. We can see what we just configured by the do show IP interface brief command. Let's see, do show IP interface. Let's see, let's exit. There we are. So we have our sub interfaces, but you see they're still down in the IP addressing in the protocol. That's because they're not actually connected to anything, so they're not running. But once we connect them and enable them, they will be. So let's see. They're all down for now. Then we go. And that was red before in the flags. Now they're negotiating. If you speed up, it's green. So that's good. So we need to do the same thing for router 2. And we'll just essentially copy and paste all this into router 2 side. VLAN 50. And the last one, and we're making sure we enable our interface, the very last part. Okay, it didn't like how we ran those so close together, so let's try it this way. This isn't a response to go ahead and copy to the non-volatile RAM, so it didn't like that. So let's run these separately. Press enter there. Okay, great. So now we're gonna go ahead and go to our next step, which is step 7. Which is we're going to route between neighbor routers with the OSPF, open shortest path first protocol, which is a link state protocol. It's based on least cost. Each of these interfaces will have a cost associated with them, and when we start running the OSPF, we can look into those costs. And the cost is just a way to say, if you have a certain bandwidth usability or capability, how much of that is the device, or excuse me, is the interface using at the time, and what label or what number or metric does it have associated with that type of interface. So if it has a metric of 5 for a gigabit interface and it takes 5, and suppose there's a thing called designated routers, backup designated routers in OSPF, but suppose router 1 is the designated router and router 2 wants to communicate with router 1, or router 3 wants to communicate with router 1, and they basically have a cost of 5 to get across over to router 1 because of the type of interface connecting between router 1 and router 2. And certain interfaces, that cost can also be adjusted with commands like auto cost bandwidth reference, I think. There's a host of different things we could do with OSPF, but we're here to share the network so that way all the VLANs can communicate between one another via the routers. So the next thing we need to do is configure between neighbor routers in OSPF protocol. Add the OSPF process 1 on all 3 routers, and the routers will share area 0, and then we're going to share the OSPF process per interface, so on all 1, 2, 3, 4, 5, 6 interfaces. So let's go ahead and start with router 1. That's going to be router OSPF 1 process, and that'll enable the OSPF process. And then for this interface G01, we'll start the process on. We run IP OSPF 1 for the process, and area 0 because in OSPF routers share areas in order to communicate with one another and share the networks that they operate on. So let's go ahead and configure IP OSPF 1 area 0 here as well. And then we'll go ahead. Now we need to go over to router 2. And we'll configure our router, same OSPF process of 1 on interfaces G01. Get a better view. And we run IP OSPF 1 area 0. And same thing for G02. Now we're at router 3. We're share the router, the OSPF process through router 3. Needs it configured on both of its interfaces. Now let's go ahead and apply these. Okay, good. So now we have the OSPF process enabled per router. If I go ahead and speed up the packet tracer time, we can start to see OSPF building neighbor adjacencies. When there's more than one router, they'll pick a designated router. The routers pick a designated router other between them, because you could only have one designated router, one backup designated router, and the other one becomes a designated router other. So you're only going to see one neighbor relationship form on 2 of these routers. Let's see. Let's first do. I know my favorite OSPF command is this one. So just let us know here. It's better to look with our topology. At the same time, just let us know that with the do show IP OSPF interface that we're in area 0. This router became actually area, router 1 became a truther. At least for G01, it did. That's its designated router state, and it's the designated router ID. It was chosen for our .60.1. So the designated router interface address 10.12.0.2. This one is a .2, I think. Let's see, that's our .2. So this one's going to be the designated router for router 1, which is router 2, and it somehow must have won an election in order for it to become a truther. But let's do another favorite OSPF command. Let's see, do show IP OSPF neighbor. And as we can see, currently we're in a full backup designated router relationship with 17.02, which is router 3. So we're in a full neighbor relationship. Let's check our other tables. Yes, so we're in a full relationship here, OSPF relationship here with our neighbor routers. It says exchange start designated router here for interface ID 60.1, and 60.1 was our VLAN 60 interface G00. And we also want to run the command on router 3 here. To see its neighbor states as well. So it's in a full designated router state with 192.168.60.1, and its IP address over here is 15.1, which is across. And so that's its designated router for router 3. And then for router 3's G0001, its designated router is across at router 1. So let's go ahead and go to our next step. Our next step here is to configure in-host in the proper VLAN connection. So in the VLAN connection, so we're going to assign IPs to each PC in their respective VLAN. So we got PC1, PC2, VLAN 30 will get a 192.168.30 assignment. Any IP normally besides the gateway IP that we use on the routers between 2 and 255. So we'll just choose 2, PC1. We'll choose 3 for PC2. And we're just going to repeat that for each PC and each VLAN. So there is 4 of them. So that's VLAN 40, VLAN 50, VLAN 60. Okay, great. So let's go to our PCs, configure them one at a time.
So finally, we're going to ping between VLAN 30 and a host in a different subnet in VLAN 60. Okay, great. And as you can see, we got pings returned between host PC 2 and host PC 7 and VLAN 60 between VLAN 30. We completed the Mega Lab. There's some things that I want to actually go over, and specifically in OSPF between the routers. Just make sure the neighbor relationships are correct, and anything else I find along the way, make some corrections in between them. And thank you for watching, and until next time.